Sara Karimi, which is an ML engineer at King and a PhD student at KTH. And she's going to be talking about learning from demonstration in reinforcement learning. And I leave it to her.
Hello, everyone. Need a moment to share my screen. Can you see my screen? Okay, good. So yeah, I'm going to talk about learning from demonstrations in reinforcement learning. And here are an overview of topics I'm going to go through. I'm going to talk about imitation learning in RL, demonstration guided RL, skill-based RL, and RL at King. So imitation learning in RL can be thought of as a problem that we are given a set of demonstrations or a demonstrator, and the goal is to train a policy to mimic these demonstrations. While in a normal reinforcement learning setting, the aim is to learn a model using exploration and exploitation in the environment. In the imitation learning side, we are trying to learn that using by imitating an expert policy. So the goal here is to take the best of both worlds and have a better performance, basically. Demonstration guided RL is a topic that explores different ways that techniques from imitation learning can be used in reinforcement learning to achieve a better performance and solve challenges. One of these topics is that we can use techniques like behavioral cloning, that is a technique in imitation learning, for initializing, regularizing, or guiding the policies during RL. And the second one is to use demonstrations in a replay buffer of an RL algorithm. And the third one could be, for example, extracting or building a reward function from the demonstrations and combining that with the reward that we get from the environment. So in the first topic, I mentioned here a few papers that actually worked on this idea. They try to not only use behavioral cloning for initializing the policies, they also use the demonstrations further throughout the training. They believe that at different stages of training, different parts of the demonstration data can be more useful. In the second idea, they worked with a replay buffer, which is basically a piece of memory in reinforcement learning algorithms where the agent keeps the experiences that they have during the training in order for them to be used again and replayed again in the environment to have a better and more efficient training. So the idea here is that part of this replay buffer or this piece of memory can be filled with the demonstration data to guide the exploration better. And these are some of the papers by DeepMind that worked on this idea. The third use case is that, which I mentioned in some of the papers that I mentioned here worked on, are the idea of building a reward function from the demonstration data. And they use different techniques for combining this reward function with the reward that they get from the environment. The other topic is skill-based RL, which is a very interesting topic. It's the idea is that we are given a data set of task-agnostic demonstrations, and we want to extract a set of behaviors or skills using, for example, supervised learning or unsupervised learning algorithms. And when we extract this set of behaviors or skills, then we can train a reinforcement learning algorithm that looks at this set of skills as its own action space. So it will work on top of these skills. And this is an example of a paper that actually has been basis for a lot of recent works. The algorithm is called Spiral. Maybe you have heard of it. But they propose an autoencoder model, and they learn a skill embedding using this autoencoder from the demonstration data, from the offline data. And then later they apply online reinforcement learning algorithm that learns a policy that outputs basically these skills. This is also another paper that works in a similar topic. I'm gonna just go fast to get to the King part. So here at King, we are aiming to build a playtesting bot to validate the quality of levels in the games. And for this, we have tried different techniques, but we are also focusing on reinforcement learning. And one of the major goals of this agent is to provide human-like behavior. So the journey of reinforcement learning started by looking into reward shaping. We started designing reward functions that were objective-based. Basically, they reflected the objective of the levels. And then when we saw good results from this stage, we further moved on to skill learning. This was roughly when I started my PhD journey at King as well. So the idea here was to build hand-engineered skill-based rewards. The idea came from how humans learn certain skills when they play the game. So we reflected that idea in form of a reward function. And then we also got more positive results, and we further moved on to skill-based RL. This is a work in progress, and the idea here is to use this big data set that we collect from users' play and to learn a set of behaviors and skills that our reinforcement learning algorithm can work with and can make the work easier for the reinforcement learning algorithm to learn how to play the game. That was the end of my talk, and thank you very much.
Thank you so much, Sara, for presenting this. It was very interesting.
Yeah, thank you.
I have one question that I didn't write down, but okay, there is another question, so I'm going to hold mine, actually. Okay. Does it make sense also to add negative samples if we could easily find them in the application domain in the demonstration guided reinforcement learning so that RL agent could also see the negative skills it should not learn?
That's a very interesting question. I know that there are a lot of works done on demonstration data that are from non-experts. So they are not necessarily from like positive examples, as you mentioned. They have both like mix of good and expert and non-expert examples. I am not sure if you can how you can formulate that for the agent to learn from the mistakes, but I know that there are a lot of techniques that can be used when you have a data set of mixed skills, basically.
Thank you. And my question was actually, what do you think has been the most fun part of applying RL at King?
I think the most fun part is when people ask you, what are you applying RL to? And then you say, I apply it to play Candy Crush. And of course, I think this is an interesting thing because all of these techniques can be applied in a lot of different domains, for example, in medical domain or in automated cars. But having to interact with a game and try to use these techniques for a game, I think that's the fun part for me.
That seems very reasonable. I loved your answer. Okay, thank you so much, Sara, and thank you to all the amazing speakers we've had today.